and welcome. My name is Amber Okroi-Taylor. I decided to call this Deciduous Springtime River and Creek Microcosm Experiment because I feel being in a deciduous temperate biome is pretty relevant. In the background here is a picture of the first field site sampled of the Kankakee River in Illinois, where I live. I appreciate your time, and hopefully you find something interesting and useful here. In a world that is more interconnected than ever, ecology gives us an opportunity to look at the world from an empirical perspective. Through this lens, we can validate observations about our environments, from our most local perspective to even our place on the global scale. Discovering how species of all forms interact among each other and with their environment appeals to our social nature as human beings. In a world that seems to be getting smaller, realizing our individual impact is even more important. Taking a local sampling and observing it can help us realize the world everywhere around us, quietly existing and fueling an unseen network. An empirical perspective is based on, concerned with, or verifiable by observation or experience rather than theory or pure logic. Ecology gives us tools to better understand the world we live in, from the microscopic to macroscopic, the local scale to global scale. It can also give us a better perspective to better appreciate the world we live in. In any good experiment, there are questions to be answered and assumptions we might make, but we can narrow some purpose of experimentation by posing a hypothesis we can actually test and learn from. My hypothesis for the project stated, if there is a primary producer to capture and convert energy from the sun, then life in the microcosm will survive. And how will we test this? By observing autotroph producers and heterotroph consumers, their interactions, and whether they survive or not. To get going on our project, first we need to gather our supplies. A clean, clear jar with a lid, a measuring cup, a container for vegetation, and a camera. Next, we need to identify a suitable site where we can collect our soil, water, and vegetation. There may even be invertebrates to collect. For my own microcosm, I filled it with about 300 milliliters of soil substrate, or 1.25 cups, in my first jar. And for my second jar, a little bit more of 350 milliliters, or 1.46 cups. After collecting soil, it's time to collect water from the same site, making sure to still leave air in the jar. In both my jars, I added 400 milliliters, or 1 2/3 cup of water. The next step is to collect a variety of vegetation grown in the same area. For my own project, at my first site, I was only able to really get aquatic grasses. And for my second site, I was able to add mossy rocks. If there are invertebrates to collect, they could be added. At my first site, there were snails, and I added a large one. Later, to discover that I had grabbed 3 smaller ones with my soil, too. Now that we've contained all our elements, it's time to close it up and place it where it's going to live for the next few weeks, the remainder of the project, and let that sediment settle and start recording our observations. When it came to observing the microcosm after the sediment settled, I found it pretty exciting to see how many visible life forms were actually gathered in only a few cups of soil and water, especially considering these were just the ones I could see. Though I had intentionally added 1 snail in the first experiment, 3 others were also there, along with a pair of crustaceans, commonly called scuds, bloodworms, aquatic worms, water fleas, and a sow bug. Unfortunately, by day 8, only 1 small snail was visibly active, and by 10 all heterotroph activity would cease, and the water had taken up a grayish color, and all plant life would appear blackened. This set of events prompted me to start a second jar. Site 2 was chosen because upon returning to the original site, it now seemed clear that public activity is a degrading factor on its shoreline, and viable plant life did not seem present, even though this day the waterline had receded when it was flooded originally. In experiment 2, I went to a creek and was able to add mossy rocks and end up collecting aquatic worms, multiple types of midges, and a soul bug. For the rest of the experiment, color was the main observation to be made, along with apparent respiration, as bubbles were now frequently observed coming from the bottom sediment and residing on the water surface. By day 17 of the project, algae had been observed on both jars, although technically jar 2 was only 8 days old at this time. In jar 2, worms are still alive and active. They have grown and can be observed congregating where algae is on the side of the glass, eating it. From now to the end of the experiment, the color of the 2 jars fluctuates, mostly being green, and there are days it blooms, exhibiting an orangish color, then for the green color to return the next day. 3 weeks in, and algae is the only life left in the first jar. For a short time, it appeared to be the same for jar 2, but then bloodworm midge larvae were discovered to be active in early morning hours near the surface and eating the red algae. They seem to have been successful and are about 8 times as long as they were when they were first observed. If there is a primary producer to capture and convert energy from the sun, then life in the microcosm will survive. Was there evidence to support this? I think so. In jar 1, vegetation did not survive long enough to sustain life. Even the snails died before there was even a chance to see if algae could have supported that population. So in this case, in the absence of a primary producer, life was not able to survive. Heterotrophic life was not able to survive anyway. And when we look at jar 2, we see that algae began growing early on, and moss lived long enough to support life before algae was prolific. Still though, not all the heterotrophs lived. Those that survived on algae as a primary food source were the survivors, and a successful secondary species. Certain ecological concepts became more apparent in the process of this experiment. How trophic levels support the food chain became more apparent, as did abiotic limits and biotic succession. When we look at how the trophic levels support the food chain, in this system, abiotic elements were limited, although sunlight still could enter the system. And since sunlight supports photosynthesis, primary producers still were fueled. And when primary producers exist in the presence of secondary consumers, they too have a source of energy. In the experiment in jar 1, heterotroph need outweighed autotroph growth, so the secondary consumer community died. Meanwhile, in jar 2, the primary producer of moss was prolific long enough for algae to grow and support the growth of a bloodworm midge larvae population. Other ecological concepts that were supported by this experiment were abiotic limits and biotic succession. The law of minimum falls under abiotic limits. If nutrition is absent, there won't be a flourishing of species. Despite an abundance of sunlight in our jars, our plants did not have what they needed to grow. We can assume something else was lacking because they failed to grow even after the snail population had ceased. On the other side of abiotic limits is the possibility of overabundance. In jar 1, most of the plants were aquatic grasses, and there is the possibility that they were actually waterlogged. Biotic succession also seems supported by the experiment. On page 6 of Ecology of North America is the quote, "The composition of the local fauna also changes as the vegetation develops." It became apparent in my experiment that the only producer left in the experiment was algae, and as a result, the heterotroph that was successful was a consumer of it. Had there been other types of plant life that survived, maybe some of the other organisms would have lived as well. It's very possible in these jars that the food source for most of the species never entered the microcosm in the first place. What we have as a result is a population that exists because of the type of food available. If there were a next time repeating the microcosm experiment, there are a few things I would do differently. Making multiple jars from the same site and varying where they are stored to observe would be interesting. You could have different light conditions or temperature conditions. I think another interesting variation would be to take samples from the same site during different seasons. My biome is deciduous and our seasons are very different. I think the most definite change I would make is to use a different container, one that was wider and offered a larger surface area for soil for implanting more plants. After making the jar, I wonder how much more successful it might have been had the height and width been closer, or at the very least, it was just a larger, wider jar. Thank you for taking the time to give a listen, and I especially found the Department of Natural Resources of Illinois helpful, and the Field Museum, and especially our textbook, Ecology of North America. Again, thank you for having a listen and a look. Take care and happy trails.